Thank you very much, first of all, for your time and for being here. Before I will start with the main topic of today, I would like to introduce our company and myself in the first place, a little shortly. emtec Electronic, we are a German developer and producer of special testing devices. We are located in Leipzig, and we are globally active now on the market since more than 25 years. And I'm personally responsible for sales and customer support in Germany, Switzerland, and Greece. Just for you to know who we are. So yeah, basically I've been introduced, and the topic for today have been introduced right now. We have a device which can objectively measure the haptic properties of textiles. So just to explain how do we measure the haptic properties of textiles, I would like to introduce our way of understanding how haptic impression works, because if you want to measure haptic impressions or the haptic feeling of textiles, you need to know how does the human hand does it. Yeah? And after this short introduction, I will of course tell you how the device will do it. So first of all, the overall haptic feeling or impression is determined by three basic main values. Yeah, you can see this is the overall haptic feeling. Yeah, if you touch something, and this haptic feeling, good or bad, is determined by three main basic parameters. The first main basic parameter are the macro surface variation, or the smoothness or roughness of the surface. And this is mainly determined by the textile surface structure, yeah, like embossing or something. Then the second parameter are the micro surface variations, or the real softness of the actual fiber material. And this is mainly determined by, of course, the fiber material's behavior, and can be mainly influenced by chemicals or mechanical treatment. And the last of the three parameters which will determine the haptic feeling is the stiffness. And of course, this is also be determined by the fiber's behavior. So, if the human hand is touching a surface, yeah, then this can be done in certain ways. For example, the textile can lay flat down, or when I walk right over this exhibition, I see a lot of people touching the hanging fabrics, yeah, and you can either touch it from one side, or you can either touch it from both sides. This is up to the application. But what happens is, if the human hand is moving over the surface, there are certain vibrations, and these certain vibrations are received by specific sensors in our fingertips. And these four specific sensors in our fingertips react to each of the three main parameters: smoothness, softness, and stiffness. How does it work? The first sensor, which is important for the microsurface or macrosurface variations for the smoothness, are the so-called Meissner cells. And as I mentioned, and as you can see here, the Meissner cells are responsible for the feeling of the macrosurface variations, or the roughness, smoothness of the material. The second sensor are the so-called Pacini cells, and the Pacini cells are reacting to the actual real softness of the fiber material. And then the last part, which is the stiffness, is being shared by two sensors, and it's the Merkel cells in combination with the so-called Ruffini bodies, and they both share the last parameter, the stiffness, but also they are responding to parameters like compressibility and crumble and shear forces. So now you have heard, okay, our hand can feel these parameters individually. So why do we need a device to do? There is one main problem, and the main problem is our human brain. Because even though these sensors do react individually to each of these parameters, the signals from the sensors are then transferred via the nerves into our brain, and our brain combines these informations automatically and without chance to influence this to an overall haptic impression. So we do the sensors can feel or can react to them individually, but you automatically combine it to an overall haptic impression. I like the product, or I like the feeling, or I do not like the feeling. But you cannot distinguish between each individual parameter. Why is this the fact? Also, our human feeling is influenced by our environment. For example, on a sunny day, the human hand feels something quite different, like when it's rainy. Or, for example, if you fall in love, then you feel something. When you in comparison when you get separated or something. What is also an important fact to consider is if the human hand has touched something, this depends on the testing procedure and also personal and market-specific preferences and the culture, which means Europeans, for example, to have another expectation of a good quality and of a good haptic feeling than a person from North America or from Asia or from other regions in the world. So this makes the haptic feeling and evaluation by the human hand quite difficult. I have written down here some problems with these hand feeling panels, because the traditional hand panel, the evaluation by the human hand, is still, unfortunately, the most common method in the textile industry. So to organize a reliable hand panel is actually really difficult, because the hand panel must be organized by at least 10 to 15 people, men and women separately. And the hand feel panel has to be monitored very, very strictly. For example, if you do have someone in your hand feel panel who is really not sensitive, because maybe he has worked in the garden or something, then he will ruin your hand panel. Then also the hand panel needs to be represented to the market where the product will be sold. And it needs also to be as close as possible to the actual application. I've written it down here. No matter how exact or reliable maybe a controlled hand panel might or could be, one problem still remains, and this is the problem of time, because reliable hand panel analysis needs very much time, and time is money. And often a big amount of material is produced until the panel data is available. Additionally to all of these things, the comfort of textile is more than just only the haptic feeling, because the comfort only also depends on deformation, spring back, and recovery characteristics and abilities. Which means when you have the touch and haptic by the hand feel panel, you have not all the parameters which are responding to the actual wearing comfort. You also have to consider the deformation parameters and the recovery of the material. And what are we doing now with our TSA? Now we are coming to the interesting part of today. We measure all these parameters: smoothness, softness, stiffness, elasticity, plasticity, in one measurement device, in one measurement cycle, which is approximately 90 seconds per measurement. It's also quite fast. And due to the fact that it's a machine, we have no subjective influences. We do have objective measured values. So how does the TSA now work? I said we do it in a one measurement cycle. The measurement cycle is divided up in a two-step measurement. It's blinding. The first step is a sound analysis, actually, to measure the roughness or smoothness of the surface. And then the second step is again a sound analysis for the measurement of the softness. And after the sound analysis, second sound analysis, we also do the deformation measurement right after to receive the information about stiffness, elasticity, and plasticity. How does the TSA now work? In the first place, we need a sample. The optimal sample size is 100 square centimeter as a round circle. And after you have this sample, you place it into the measuring cell, close the measuring cell. And when you push start, the measuring head is going down, and we do apply a specific load of 100 millinewton or 10 grams to the material. Why this specific load? 100 millinewton or 10 grams are more or less the same load which the human hand applies when we are touching a textile. We do it also on conscience. And after these 100 million newtons are applied, we start to rotate with our measuring head over the surface. And on the measuring head, we have so-called blades, and these blades are rotating over the surface. And by rotating over the surface, we create a vibration. You can compare it a little bit with the record player. Yeah, you do have the plate and the needle, and when the needle is going up and down, you hear the sound with the music with the record player. Our system is flipped, so our needle is fixed in vertical direction. So the only thing that can vibrate is the sample itself, which means when we rotate over the surface, the more the sample vibrates, more rougher is the surface. The less the sample vibrates, more smoother is the surface. Quite easy. So, a short graphic to explain it. Yeah, these are our blades. Oh, why does this not start? Okay, technicians do not know why the graphic do not start. So basically, this represents the sample surface, and these little bumps here. Yeah, these are the structure of the surface, and more rougher the surface is, the more the sample itself would vibrate. And what do we receive then? This is our software graphic. We analyze the sound of this. Yeah, on the x-axis you have the frequency, and on the epsilon axis you do have the intensity of the sound. And you can see here, more higher the peak is, the more the sample has vibrated, and the more rougher is the surface. The lower this peak is, the less the sample has vibrated, more smoother is the surface. This is the first parameter which we measure. Then again, in the second measurement cycle, we again apply a load of 100 millinewtons on the surface, and we start to rotate a second time. But this time we do not consider the vibration of the sample. This time we consider the vibration of the blades themselves, which means more harder the fiber material is, the more the blades themselves will vibrate after moving over the surface, and the softer the fiber material is, the less will the blades vibrate. I hope this will work now. It's the principle like stick and slip. Again, not working. Okay. Later on, I do have a short video to show you how the device will work. I hope this video will work. And again, we do evaluate the peak in our frequency in our frequency spectrum. And more higher the peak is, more harder was the fiber material. The lower the peak is, more softer is the fiber material. Also quite easy to evaluate. As I have mentioned before, after our second sound analyzers, we do also have the deformation measurement right after them. And in this time, we increase the load in 2 cycles from 100 to 600 millinewtons. So from 100 to 600, relax to 100, increase again to 600, relax again to 100 millinewtons, and receive then the information about the stiffness of the material, elasticity, which means how good does the material came back to its original shape, and plasticity. Is there any plastical deformation when applying a certain load? Which is also important for you, this load can be increased up to 15,000 millinewtons. So if you have a more stiff material also, you could increase this load also. So this will again not work. Great. So I hope this video now will work to show you, to give you a short overview how the device will work.
The video's not synchronized. Sorry, they're not synchronizing. Let's check it before.
What's this problem?
It doesn't work with our system, unfortunately. The video's not going to show. It won't let it, sorry.
Okay, yeah. So there's some technical issues. Unfortunately, I cannot show the video. This is quite unfortunate. Yeah, so with these individual measured parameters, smoothness, softness, stiffness, elasticity, and plasticity. Our software is later then able to also calculate a so-called hand feel value, which means this is one number which then also can correlate up to 99% to the human hand feel. Yeah? So we can actually correlate this value. But these algorithms which we can create must be also market and product specific. So, short information about users and application areas. Of course, more or less everyone could use this device, from fiber makers to chemical suppliers to fabric suppliers, retailers, universities, institutes. It could be used for research and development, benchmarking, complaint management. This is actually a good topic, because I heard when I walked right here, I spoke with a lot of guys, and they already told me, when we get in touch or we get in contact with our customer about quality, then the customer, of course, feels the material, and then there are certain complaints about, this is not a good quality. It is a good quality, but because the human hand always feels subjective, makes these conversations very complicated. And with our objective measured values, even the customer and the supplier have reliable values to rely on. It also could be used as an incoming control tool for marketing and sales whatsoever. We also do have additional modules for the device, which makes it even more versatile, which means we can also measure very thick materials like towels, carpets, rugs, or anything, or also very narrow materials, like seat belts for cars, belts for bags or whatsoever. And we also do provide additional modules to measure, for example, also the compressibility of the material, or the crumble ability of the material, which correlates to the drape. So you can see the device is very flexible, and has a very wide range to use. And this leads me now, unfortunately, a little bit too soon to the end of my presentation. I'm sorry for these technical issues. And now I hope you have a lot of questions to ask to me.
So can we first show our appreciation to Eric for his detail? And at the same time, I should be humble and say, we're going wrong on our technology. It's not Eric's technology that it's going through. Now, I have a pile of questions because I'm interested in haptic technology, but we're at the stage where I am welcoming questions from the audience and also from the virtual world. So does anyone want to kick off the questions before I start to pick on him myself? So just by way of introduction, can I point out that if we go back to the turn of the millennium, we tried the same experimentation with color match technology. And for the first 5-6 years, it just did not work. We just couldn't get it accurate enough. Now, color match technology is a norm, and we accept it. I see haptic technology being very much on the same growth curve, but it's going to happen faster. Now, there's several people doing haptic technology, and this is the one that my boss sees as having the most potential. Marco's a lot wiser than me, so I'm quite happy to let him lead on it. But I've got a virtual question coming in, but I'm happy for the audience to ask as well. So the virtual question, fantastic technology. Do you have a database of already tested textiles, like cotton, silk, polyester, all being compared?
Unfortunately...
Isabella, thank you for the question.
Yes, thank you also for the question. Unfortunately, no. The answer is unfortunately no, because textiles have such a wide range, starting from the origin of the material, how the yarn is made, how the textile structure is made. So we do not have, unfortunately, now a database, because it's all already a question where is the product should be sold, because I mentioned before, for example, Europeans have another expectation of a good quality than people from Asia or from Northern America or something. So a real database we do not have, but we can provide the individual measured values which help the customers then to improve their products. And this is from my point, this is the more important thing, because this is what the human hand cannot do. The human hand can only say, I like product A more or less than product B. But the human hand cannot say, why do I like it or why don't I like it? Or if you can set a benchmark tests, yeah, if you have your product in comparison with maybe the competitor, you want to evaluate why are we not as good as them, and this gives you the information. Okay, what to do? Yeah, do we have to make it a little bit more smooth? Do we have to improve the softness? Do we have to make it a little bit more or less stiff or whatsoever? Yeah.
I agree with your answer, but I would also be the cynic and say, I would like to know what the result is for the norm of the fabric. And I appreciate what you're saying. The norm is not normal. There's such a massive variety. And one of the big issues on this industry is about textile break-offs from the laundry. We're now doing testing, which means that we know the average shed of the average fabric. Now, that has meant testing an awful lot of fabrics to try and get, so not only are we testing new fabrics from a good variety of the partners here, but also UV age fabrics, because that, of course, changes the haptic feel. So I agree with what you're saying, but I know for this industry, you have to meet them halfway. Isabella, thank you for the question. You've heard the answer. I like it, but I don't agree with it. Any more questions?
Maybe in the future. Maybe in the future we do have. Yeah.
I like the attitude. I know the future is cooperation and working together.
Yeah, so the device, just to give you short information, the device itself is not quite new. So the device itself exists since I think 2008. It was originally developed for the tissue paper industry, and so napkins, handkerchiefs, toilet paper, so on, something like this. And in the tissue paper industry, it became industrial standard. So more or less every producer of tissue paper in the whole world has at least one of these devices. There we have sold over the last years more than 400 or approximately 400 of these. So the device works, but something like database we do not have until now.
Just a small question.
Yes.
About the cost, because hand feel has no cost. Okay, if you do this by hand, so can you give an idea, roughly?
So the finger does have costs. So the people which are building the hand feel panel, you need to pay them, yeah, and that's why the fingers have costs. And the device roughly costs 80,000 euros.
80,000 euros
80,000
is actually reasonable.
Yeah.
I was expecting it to be the wrong side of 100.
Okay, I can tell this to my boss.
Okay, because I'm starting to run out of questions. Now, what will happen is that if you don't want to ask your question publicly, we're going to tie you down over there and people can come and speak to you on a one-to-one basis. But more importantly, can I ask us all to show our appreciation for that presentation?
Thank you very much.
Now, those of you who are still waiting around, it's been a long day. We've never had so many presentations going on. We still have one final panel from Anna Rovod. If you don't know Anna, this is Anna in the red leather jacket. She leads at Green Room Voice. If you are not familiar with Green Room Voice, it's the collection of collaborative thinking for more sustainable action. They actually have a display right down at the end of the hall, just the other side of the food area. And what Anna and Sarah do is that they get people together talking. So the answer is collaboratively better. It's not just being excellent. We need a lot more people to be better. So Anna's got a panel, 2 people on stage, 2 people zooming in virtually. We're going to start in 30 minutes. So you've got a time to stretch your legs, have a break, grab some water, come to the last presentation. When Anna's panel is over, we're allowed to break out the beer. So I'm happy for Anna's panel to finish at 5:05. But yes, 30 minutes time, we're going to start on the panel. The panel is on the subject of regenerative agriculture, which is the incoming vibe. It's not cotton, which is less bad, or it's not textiles, which are less bad. It's textiles, which are positively good for this planet. And as the father for teenage daughters, if my daughters are going to be buying stuff which is doing good for the planet, I might have to give them money to do it. Half an hour's time, Anna with the panel.